corn college and soybean school. So I'm going to talk about some of the water management considerations. Feel free to pop in and ask questions in the middle of my presentation so that if there is anything that is not answered, I'll be happy to kind of just take a pause and answer that question. I kind of formed the outline just thinking about what I want to share. So if you have some questions that really you would like answers to, go ahead and put those in right now in the chat. Um, so I'm hoping we will kind of revisit that 2024 growing season. I want to spend a little more time on this second question about the role of drainage and water in the plant growth, and especially as it relates to nutrient use efficiencies. So there is some new publications that have come out, and this is kind of my first attempt to try to summarize those for you folks. And lastly, I'm hoping to talk about some of the suggestions that may be helpful for 2025 growing season. That was the thought, but I think it might end up being more general discussion. One thing I do want to kind of start with is typically, if you're talking about Ohio or the Midwest, we are thinking about farming in a water-rich region. We have more water than we need in any given year. So, which is kind of a blessing for us, in my opinion, because of this, if we did not have water, we would have been thinking about irrigation. Right now, a majority of our landscape where we're growing corn and soybean, we do not have to think about irrigation. We only have to think about getting rid of water, which is what my program focuses on, is drainage. So if you look at a typical crop growing season, I'm using corn as a example. This would be very similar to soybean. Things might shift a little bit left on this graph if the planting dates are a bit earlier. But in general, if you look at our annual distribution of precipitation, so these are 30-year averages of monthly precipitation we get. So we get anywhere between a couple inches to 4 inches in a month over time. And what you see is early spring, what I call this as too much water situation, where there is really no demand for that water, but the water is still coming in. Sometime between April and May, you get your corn or soybean planted, and the plants start using that water. So this green graph is the consumptive use by the crop. And you can see that as the crop is growing, the demand per day is increasing. So by the time you get into July and August, the corn crop is able to pump about 1/4 of an inch per day of water from your soil profile, which is a significant amount if you think of it that way. So what happens is, naturally, as you get into those summer months, the crop demand goes up significantly higher than what the precipitation in that month could provide. Of course, you have some carryover moisture from these spring months, the moisture that was retained in the soil profile that might benefit during this. But for, I would say, these couple months, we have a situation where there is not enough water. And this is not new. We've been farming this way for close to 100 years or more. We know that our crops that we grow here in Ohio, especially Northwest Ohio, have a natural deficit of about 4 to 6 inches of water. And we still are able to get the yields that we get with that natural deficit. Things get a little bit complicated, such as last year, when this deficit increases. So as I said, that 4 to 6 inch is the pure deficit based on the difference between the consumptive use and what you would get as a precipitation only during that time. If you account for some of the carryover moisture, especially in the heavy clay soils that we have, maybe there is an inch or so of benefit that you get from that soil moisture storage. So why am I saying all this? What I'm trying to suggest is we have really two main issues when it comes to water management. If you go to Ohio's Country Journal and search for crop progress reports, uh, they are weekly published crop progress reports, and anything you read between the months of April and June, you would see these words pop up: wet conditions, too much rain, delayed planting. So around springtime, around planting time, we actually have too much water situation. And then I'll have a slide later on that shows how the crop progress is reported between July and September, but you can already guess what that looks like. So for that wet season is really where I feel like the function of drainage is very, very important. Number one, we want to be able to get out in the fields and be able to plant. There are uh, two things that we need to achieve. Number one is we need to have trafficability to be able to get out in the fields. Number two, uh, even if you were able to plant, we need to make sure we have good emergence. Laura, this morning, kind of refer to that as well. The kind of uncertainty we have in spring months. There are some years when even having drainage doesn't necessarily help you, uh, and the crop emergence gets affected. So as you get into that late season, most of the crop progress reports are dominated by hot weather or dry weather kind of a reporting. And this was true especially for our 2024 growing season. So I think you have heard enough from Aaron and some of the other speakers. This is my perspective. I don't want to bore you with the same images, but it was very interesting from my perspective to see how that drought kind of migrated from Southeast Ohio towards Northwest Ohio. And Aaron did mention this in his presentation, that how that drought creeping into Northwest Ohio affected soil moisture. So this is probably the same map that Aaron had shared with you. In the month of December, our soil moisture levels were about 0 to 5% of the 30-year average soil moisture. If I take the 30-year average soil moisture for that month, I'm guessing most of the soils are at saturation or field capacity. So either way, there was definitely no moisture or very less moisture down to about a meter depth or a 3 feet depth, which is the typical depth for tile drains. So what you can say is there was no water above the tile drains. Maybe soil was a little bit moist, wasn't enough. As Aaron mentioned, in February, we seem to have recovered from this, but we still seem to have lower moisture content. And I keep thinking about, like, if I was a farmer, how would I interpret this? And should I be worried about this whole thing going into my planting season? So this is my thinking. If it makes sense to you, take it. If not, then um, uh, I would say just wait and watch what happens this spring. So a little bit of a soil physics 101. Again, these are very rough estimates. Um, if there is soil scientists in this group, please don't shout at me. But imagine your soil profile above tile lines is about 3 feet deep. Okay. Now this soil is not just soil. There is about 50% of the soil is just a pore volume, right? Just the empty space. So if you really shrink all the soil particles down to um, down into one place so that it becomes solid mass, about half of that soil is empty. That's where the water or the air come in. So imagine if you were to fill up a soil profile completely, you need about 1.5 feet of water. Does that make sense? So 1.5 feet of water is what you would need to fill up a 3 foot of soil profile, which is about 18 inches of water. We know that our soils are never bone dry. There is no way you can take all of the moisture out of a soil profile. So typically, you do not have this kind of a deficit in a soil profile. What you have really, especially in spring, a lot of times our soils are close to saturation. or they are at field capacity. Now, again, in 2025, we're sitting in a situation where maybe they're not at field capacity, but somewhere between field capacity and completely dry condition. So in a normal year, in a normal spring, we would have needed only 2 to 4 inches to completely saturate that soil. Um, and then the rest of the precipitation that you're getting in that season is just drainage or surface runoff. And I'll make this point on my next slide as well. So in a typical spring, our soils are so wet that they don't really need too much water to absorb before they actually start discharging that water as tile drainage or surface runoff. Okay. My guess is that for this year, um, I think this reporting may or may not really tell you what the real situation is out in the fields. The best indicator you can have is if you're driving around or if you're out and about, look at your tile outlets and see whether or not they are flowing. If they are flowing, I think you're okay and you're going to recover most of your moisture in those soils. So this was a bit of a too much of a soil physics thinking, but I think we're going to be okay going into the planting season. What happens after planting, it all depends on how much precipitation we get in the months of April and May. Just know that drainage does not remove all the moisture. It only removes the moisture that the soil cannot hold. Excess water is what we're getting rid of. Here is my optimism. As I said, we probably need anywhere between 2 and 5 inches of water to replenish that soil moisture in our soils in Northwest Ohio. In an average year, average spring, we have historically received about 15 to 20 inches of rain or precipitation between the months of November and April. So my question to Aaron would be, what is the probability that we will get at least 5 inches of precipitation between now and March or April? Hopefully we'll recover from this soil moisture deficit, and I don't see that as a big concern. What I really got into thinking is I wanted to see what the drought conditions have looked like in the past. So what you see here is starting in 1895, going all the way up to 2023, total percentage of land area in Ohio that experienced some kind of dry condition, whether it was that D0 drought that Aaron mentioned up to D4, or some kind of a wet condition where it goes from 0 to 4, again, extreme wetness as you go into that W4. And what you see is between 1895 and 2023, we have had both. We have had dry conditions across the state. We have had wet conditions across the state. So this is not new to us. Our natural weather is such that we are used to seeing both of these. It's only the years like, for example, 2012, which might be somewhere here, where it gets very tricky. And the reason is because the timing of that drought matters. So if you can revisit your 2024 growing season, especially if you're a producer from Northwest Ohio versus Southern Ohio, if you don't mind, maybe put in some comments about whether or not you saw a yield impact from the drought that we saw in 2024. It seems like Northwest Ohio wasn't hit as bad as we think it might have in terms of that drought impact. But if you look at last 30 years of crop insurance reporting, we do see that water tends to dominate as a category for reported crop damage. And lack of water as well as too much water are both responsible factors for that crop damage. So over 70% of those crop losses are reported because of water-related damages. So water management does become important. As I said, the drought is not new to Ohio, but in our case, I think that wet spring really affects our ability to get in the field and be able to plant. And that's why it's on our mind more often than drought. We get into this drought kind of a situation maybe once a decade. That is increasing, maybe because of two reasons. Number one, as Aaron mentioned, there's warming of growing season, especially summer months, and we are evaporating a lot more moisture than what the deeper soil profile can provide during those months. And the second thing is the periods when we get these rain events during the months of July and August, which really serve as blessings. They are get coming in very late. Maybe they were 7 to 10 days apart in the past. Now they are somewhere between 10 and 15 days apart. That 5 or 6 days of extra drought stress is really affecting our crops. As I said, we have intensive drainage or drainage to help manage our wet conditions. I don't think we necessarily have that kind of a mechanism to manage drought stresses. And that's what we should be thinking about growing into this future, especially 2025 growing season or the next decade. How do you think you might manage the drought stress if there was another drought that would come in? And there are ways we can get creative with our existing drainage systems to manage that. I wanted to make sure that I am accurate with this. So I took a slice of those droughts from or drought and wet conditions from that timeline that I showed. And I'm only showing you 2011, 2012, and 2013. So most of you have a good memory from 2012, which was a drought year. And what I did was I put those crop use curves on here just to show you how that timing might look like for crop season. But really what you're looking at is this peak demand window, which is that red window, and the too much water window when you're planting the crop, right? So you can see that in 2011, we did have wet spring, which probably affected planting, but we also had wet summer, which probably helped in on the drier part of the growing season by for bringing a little more moisture in the soils. In 2012, the drought actually fell exactly during the window that you have the peak demand uh, for corn and soybean. And 2013, I would call this more like an average year for Ohio. We do get wet weather in spring. We get some rain in the summer, but overall it averages out. Not a lot going on in 2013. I would say maybe call this a normal year. If you look at the state average for precipitation, we got 150% of our 30-year average for precipitation. 1.5 times more rain than 30-year average. In 2012, it was about 75% of 30-year average, but most of that deficit was limited to those summer months. As I said, 2013 is a good representation because we got close to 100% or close to our long-term average precipitation. This was annual precipitation. I'm not showing you seasonal precipitation, but look at what happens to state level corn yield. This is state level average, but in a wet year, the average yield for corn was about 150 bushel. In a drought year, we got hit 120. In an average year, we're at 174. So what worries me is from 174 going down to 120 is a big contrast compared to going from 174 to 150. Again, you take any slice on this time scale and all of these numbers are going to change. But I hope that this puts things in perspective, how water plays a role and how drought is where we do not have a good preparedness for our management. So what I'm saying is, I think not just managing drainage, but managing water is kind of becoming necessary for us now. It is going to become a necessity in the future. Most scientists have pretty much concluded this. But what I'm saying is not from the perspective that, oh, I'm really scared about this necessity. I feel like we're missing out on the full potential we could achieve on our crop yields if we had all of that, you remember that 4 to 6 inch deficit that we had. If we had that kind of a water available, we could reach the full potential that these soils have in terms of productivity. So, so that's where the conversation stops on like reviewing our growing season and how that water might play a role. I do want to talk about some of the new things that have come up in terms of how drainage connects with crop yields and nutrient use efficiency. Some of this you have already seen in my presentations. Some of this may be new. There is a really nice extension fact sheet that was published a long time ago that talks about 20 benefits of drainage. And there is a long list of benefits that you can think of. But there are things like increased supply of nitrogen, longer growing season, fuel savings, uh, in fact, better ability to sustain through the droughts. I think this goes to the fact that maybe drainage enhances crop root growth into deeper soil profile, which might come in handy during the drought periods. But really, crop yields was a main benefit that kind of sticks in our minds, and then the reduced risk. So here is an example for what that was based off of. Dr. Glenn Schwab, who was one of my predecessors, he did a 20-year study in Ohio, which shows undrained soil, corn yield in an undrained plot compared to anything that has received drainage, surface drainage, subsurface drainage, or a combination of surface and subsurface drainage. You can easily see the crop yield benefit there, but this blue shading that you see is the interannual variability. And as you can see, drainage does take that risk out of the equation. In any given year, in an undrained plot, the yield was 60 bushel plus or minus 60. By the time you get into this range for drained plots, the yield was 120 plus or minus maybe 25. So reducing risk is a really important benefit that drainage provides. They did this for corn, oats, and soybean, and very similar results for either of these crops. Again, this was done long time ago. I continue to present this because I think this is still valid, but the hybrids that were used back then were probably dealing with different hybrids. So here is a more recent study. Again, this was started long time ago, but Indiana, Purdue University, they had a trial where they compared about 16-foot spacing, 33-foot spacing, 66-foot spacing, and 130 feet, which was treated almost like a no drainage kind of a treatment. And all tiles were at 3 feet depth. And they had these nice replicated plot where they monitored crop yields and some of the other indicators over time. If you want to take a screenshot or a picture of these fact sheets, there is a lot more valuable information that is in there. It's a series of 3 fact sheets that they published out of this research recently. Here is what they found. I'm treating this 130 feet as no drainage. And for corn, what they found was there was about an 18 bushel yield advantage between no drainage or almost no drainage and anything that is drainage. Okay. But then as you get into narrower spacing, so this is almost like splitting the spacing. When they went from 66 to 33 to 16, depending upon what you're looking at 1 to 6 bushel yield benefit between the spacing selection. So I think this is very consistent with the Ohio study that I showed, that the biggest leap you're going to see is when you drain an undrained soil. That's when you see the biggest leap. And then anything you do on splitting the spacing or intensifying drainage, you don't necessarily see that clear benefit. It does help you bring uniformity, spatial uniformity within the field. So here is what is a more complicated version of how they presented the data. So this one was the average for all of the study. I think this was about 35 years or so. They plotted every year and every plot on the graph, and you can see no drainage was these black circles. And in some years, the corn yield was really, really impacted. But again, another example where that black line is the no drainage and all the drainage scenarios are separated from the black line. And within that drain scenario, yes, narrow drain spacing towards the end did help a little bit. But what is interesting to me is the first 10 years, they almost saw no difference between drained and undrained plots. And I have no idea how to explain this, but this was an observation they had. They had something similar. You do not see the lines because their conclusion is that soybeans, there was absolutely no statistically significant impact of drainage as a treatment, and it varied from one year to another. So for example, in this 2002, undrained plots actually had highest yields compared to any of the drained plots. And this completely reverses in the year 2018. Undrained plots had lower yields and drained plots had higher yields. Either way, I think what this study concluded was timely planting was a major benefit for soybeans, and crop yield plus timely planting was the major benefit for corn. One more thing they kind of indicated, which was very interesting to me, is the narrower the drain spacing, the more leaching of nitrate from that soil profile. So if you're thinking about narrower and narrower drain spacing, I think it is important to also consider how much nitrogen you're going to be losing because of a faster drawdown that is going to happen. As you get narrower and narrower in drain spacing, the water table recedes faster, and which indicates that the water is getting out of that system faster, and which means you're leaching that soil profile at a faster rate. You are also likely to increase the total discharge from that field with a narrower spacing. So that was interesting to me. Again, I'm happy to share some of these slides eventually, but there were some key conclusions. I highly recommend you look up these fact sheets and try to study a little more. But as I indicated, there was clear difference in corn yields and the potential for the nitrate leaching from a narrower spacing. Very much confirms what we know, but at least we have a good connection now with a more recent study. So that again brings up a question like excessive drainage or overly narrow spacing. Does that mean you're also going to affect the soil moisture deficit in that field? And again, I don't have conclusive data on this. For now, we have studies established to look at this, but in the long run, I think there may be some effect. Another study that came out of Iowa, Iowa State University, Dr. Mike Castellano was the lead on this, and they published something comparing drainage, no drainage, controlled drainage, and how that affect nutrient use. I'm not going to go too much into details, but I'm going to show you some of the conclusions they had. They did similar to Ohio study. They did say that they actually got relatively higher yields in no drainage, but there was a huge variability, interannual variability. Main advantage of drainage was improved trafficability, earlier planting. Drainage actually compared to undrained plots, drainage compared to undrained plots reduced nitrogen surplus, which means that there is less nitrogen lost from the soil profile, which in turn means that you're improving your nitrogen use efficiency. Fields with drainage systems, especially if you are bringing in controlled drainage into that equation, actually required less nitrogen fertilizer to achieve optimum yield. So here is that data that talks about that optimum yield, the AONR, or agronomically optimum nitrogen rate. For no drainage plots, they needed about 0.77 pounds of nitrogen per bushel of corn. Conventional drainage treatment needed about 0.72, which is about 0.05 pounds less than undrained scenario. But with controlled drainage, there is almost like a close to a tenth of a pound of nitrogen per bushel difference. So controlled drainage kind of played out a major role in helping enhance the nitrogen use efficiency. Um, a lot of times, I think I'm seeing a uptick in producers wanting to install tile drains at 15 or 20-foot spacing, where our recommended spacing for that soil is 40 foot. And there is a reason why you're trying to do this. Yes, it can definitely provide trafficable conditions, maybe some extra trafficable hours or days. Um, um, it can definitely make your yields uniform. You'll see illustration there. Think about some of the consequences of that and maybe plan for it. If you think that there is going to be a little more leaching of nitrogen, we may have to think about how to keep that nitrogen in the field. Um, is there going to be earlier drying of the soil profile? I have done some modeling scenarios, and I think there is chance that you might be causing some drying in unusually dry years. In average year in Ohio, I don't think I'm worried about this as much. But here is what I'm thinking. Maybe if you're thinking about narrow spacing, also think about these 3 bullet points. Um, think about putting those tile drains shallower. That would keep some of the nitrogen in place. Controlled drainage, as that Iowa study indicated, controlled drainage may be very important if you want to minimize the loss of nitrogen. And then you could think about, if with a closer spacing and shallower depth, sub-irrigation as a practice is very much possible. So those are some of the things that you could think on top of splitting the spacing. I do want to kind of just make sure you're aware that these studies are only focused on poorly drained soils that actually need drainage. So don't just take this and apply it to a sandy soil. You got to think about whether or not that soil actually needs drainage. Again, crops play a role. There's many other considerations you can think of that were not really included in my conclusions here. Thinking about new tile installation, Ryan, how are we doing on time?
We've got about 9 minutes left.
Sorry, I didn't hear you.
About 9 minutes.
Okay, thank you. A quiz question for everyone. You have probably seen this before. Where is the tile line in this picture? And if you thought that it's in the middle, that's the right answer. I'm not gonna wait too long. You can see that the most benefit you get for your crops of drainage is right above a tile line, because that's the area that is going to drain the fastest. That's the area that is going to drain the first before the area away from the tile lines, which also tells me that maybe that's the areas away from the tile lines are the ones that are likely to dry out slower than this zone. So you got to think about, if you're going into that field too early, before the entire field has dried out, are you causing more compaction? And is that causing less drainage or poor drainage in those zones than simply the lack of appropriate spacing? So in a classic drainage design example, we suggest that you should design your drain spacing so that you are getting uniformity between two tile lines. If you're designing your system this way, this is wrong. And you should definitely bring those tile lines closer. But if something else is causing that, you should probably think about fixing that issue rather than trying to fix the invest into too much drainage. Really, the goal for a drainage system design is to bring that water table from surface down to about a foot in 24 hours. As long as your system can do that, I think your crops are going to have the same effect from drainage, no matter how intense the drainage is. So Dr. Skaggs long time ago kind of indicated that this is the golden rule of drainage, that drain only what is necessary for good trafficability and crop growth, not a drop more. What he really meant to see is, if you're investing more and more, you're essentially just investing, the narrower spacing means you're investing more money. So your payback period is going to be longer than what it needs to be. If you're thinking about new installation or retrofitting existing installations, I have a set of recommendations. I'm going to quickly go through this. These are common sense things that you probably are already thinking about. But really think about, don't just think about, oh, my neighbor did 40-foot spacing, or my neighbor just recently split the spacing to 20 foot, and that's what I want to get. Have a conversation with your contractor or come to drainage school and learn how different factors play a role in selecting the drain spacing. Many factors play a role in selecting drain spacing. Uh, Ask about where the outlet is going to be, what the freeboard might look like. Animal guards are important. Surface drainage is the cheapest form of drainage, so that should reduce your cost down if you have ability to route surface water before you think about subsurface drainage. In a flat field, I think we're at a time point here in Ohio that every field that is flat can start thinking about controlled drainage as an alternative. But the good thing is there is cost share options on controlled drainage installations. Uh, Talk to your local soil water district or NRCS for some of that cost sharing. Uh, think about when you're sizing the main pipes, think about future expansions. Uh, Broken tile blowouts are really enemies of a properly functioning drainage system, and especially main pipes. So you got to fix those uh, promptly. During construction, I think it is important to be out there and see whether or not the construction process is actually being done at a quality that you require. Grade control is very important, and the connections, the way the connections are made and backfill is done are very important. Um, Controlled drainage came up many a times. For those who do not know what controlled drainage is, essentially what we do is put a control structure at the outlet, and instead of making it a free draining system, now you have the ability to stack up gates that would raise the water level in the structure. During winter time, if you do this, there is tremendous benefits to water quality because you don't need drainage in winter. During growing season, if you raise that water level just a little bit, then you can store a little more water behind those boards, and that comes in handy during the months of July and August. In Ohio, we have done long-term studies on this, and we have seen about 6% on average crop yield benefit to corn, 3.5% on average for soybeans, just because you did control drainage during those summer months. In dry years, that benefit looks like 10 to 15% yield benefit for corn. There is some other strategies I'm gonna skip over, but if you are thinking about controlled drainage, you may have to think about how to manage those control structures if you're doing cover crops during winter or growing wheat during winters. We got to think about how we can manage controlled drainage. The good news is I have written a Ohio Country Journal article on that whole topic. So as long as you can search for controlled drainage management for cover crops, hopefully you'll see that article there. Um, I'm gonna talk about one more practice, which is recycling. Some of you might have heard me speak about recycling. In Northwest Ohio, we don't necessarily have rich water resources for us to even think about irrigation. So this is when our drainage water that we discharge during non-growing seasons could be stored at the edge of the field in a pond, where you could then pump that back into the fields using some kind of an overhead irrigation system or a sub-irrigation system. Um, at Ohio State Lima campus, we have a new site where we are demonstrating this. We'll be conducting field days in 2025. Be on the lookout for those if you would like to know more about drainage water recycling. Uh, but there is plenty of research that has been conducted on sub-irrigation. And based on that 25 years of research, we know two things here in Ohio. Number one, drainage brings about 25 to 30 bushel yield benefit compared to an undrained field, and a 3 to 12 bushel yield benefit to soybean. But if you added irrigation as a component, that pretty much brings additional benefits to your crops. whether it's sub irrigation or over irrigation, I think these numbers would be very similar. So I think that's my last slide, Ryan. I hope I was within time.
Yeah, you're good. And I'm looking back. I don't see any questions posted. If anyone does have any questions, go ahead and put them in the Q&A. But we do thank you for the presentation, and encourage those that have a greater interest to reach out to Vinayak or to attend the Overholt Drainage School coming up in March.